So thanks for joining the talk. Name's Candid Wuest. I'm in the industry for more than 25 years on the cybersecurity side. Helped to build 2 EDR, which are still used for what it's worth. But currently I work for Xorlab, a email security provider or software that we developed in Switzerland. But it's all about AI, right? I had to do one of those buzzwords to get in, and it seemed like it worked. Of course, I shrinked everything into 20 minutes. There's more information, so bear with me if some of the parts are small. But in general, I basically just wanted to know, will we have the Skynet ransomware that kind of goes through all of your firewalls and WAFs and so on, and you're basically all out of job because nobody will defend against it, right? And if you look at it, yes, of course, you can generate malware with AI. I'm not recommending that you do it. In most countries, it's illegal, depending on what you do with them afterwards, at least. But yes, you can use any of those, depending on if you use the newest ChatGPT, Claude, Gemini, whatever. They will have some guardrails. So either you need a jailbreak to get around those, you can buy those, you can find those, or you use one of the open models like the White Rat Neo is kind of a popular one. You download some. If you can download it locally, you can also overwrite the weights so you can get around nearly every of guardrails. So assume that it is possible. But is it any good, right? If you ever try to do it, it needs a lot of hand-holding. I mean, if you just say, I want to get rich, probably not working. If you say, generate me a ransomware, it will generate you something. When I tried it, it gave me something with a symmetric key, which was still in the file, so probably no one's going to pay you millions because the key is still there. So you need to kind of do it step by step, right? Going in and say, oh, okay, maybe I should use an onion for getting a thing. Oh, maybe I should wipe the key after I used it. Maybe I should do this and this. And yes, of course, you can try and do it by saying, hey, just use this APT threat analysis report, do exactly what they did. But usually they don't really have all the information in there, and you don't really want to use the same ICs either, right? And of course, the cruise with AI is that everything is changing, right? So now you have Codex, the Claude Ops 4, and all the new models. So they are getting better. Don't get me wrong, by the end of the year, maybe next year, we will be there where you can actually do some relatively good malware with AI. But if you look at the moment, there's many other reports like Virus Total. They analyzed about 650,000 samples, and in a nutshell they say nothing really sophisticated. So yes, you can generate your small thingy, but that doesn't really matter, right? So when I read the news, it's always but it's lowering the barrier right now. Anyone can write malware. Well, they already could, right? It's not that it's something new. So for me, if we compare it with your classical malware toolkit, malware as a service, I mean, if you have no idea, right, you just Google, you find any of those hacker forums, not even on Tor, right, just on PlainNet, and pay. You probably get scammed because that's how it is. Then you learn a little bit, you pay again, and you might have your Lockbit coder or whatever. Compared to now with generative AI, if you have no clue at all, you need to find an LLM which is open, so either you pay or you find one. Then you need to have an idea, as I said, of what malware actually does. So just ransomware is not good enough. You need to know a little bit more. And at least in about 10%, 20%, it will actually have some kind of issue with the coding. So you need to know how to compile, how to debug. Sometimes imports are missing. So there's always kind of some of the issues that you need to fix. But of course, yes, once you have that, you will be able to generate your malware. And probably, quote unquote, hopefully you learn something, so yes, you might be faster in the future. But if you take that, it has been already easy, it will be easier in the future, so it doesn't really change too much. And kind of one argument to support that is, if you look at the new malware samples being found in the wild, here taking A/B tests from Germany, I mean, we're at the 1.2 billion. It doesn't really look exponential to me, right? I mean, yes, it's still going up, but it has been going up as well since ChatGPT came. So yes, some will use it, but it's not that we're seeing suddenly a new wave, right? It's definitely scaling, making it easier for some, but it's not that wave that's kind of carrying to just overrun us all. But there are a few interesting things. One of the first one, of course, is polymorphic, or to be pedantic, metamorphic malware that you could generate with LLMs. And the idea of polymorphic and metamorphic is that every time you have a new infection, it's completely changing at least the outer shell, having the same functionality, still encrypting your files, sealing your bitcoins, whatever, but it's different from the outside. People used to do that in the 90s because signatures were kind of the thing to do with antivirus, so you wanted to bypass those, right? Kind of make it like a different gift wrapper, but inside you still have the same, PlayStation or whatever you're giving away. There are Black Mamba, Chatty Catty, there are a few proof of concepts that show you. What they all kind of do is they take the malware itself and contain, or basically embed in it English natural language prompts, and then send that to the LLM and say, hey, I need a code, like a Python code, that steals passwords from a browser. And you will get something back. But because LLMs are not really deterministic, you will get something different back every time. I mean, depending on the temperature level, of course. Sometimes you will get something which does not work. You have to accommodate for that. But in many cases, yes, you can do something which will be different. Therefore, classical signatures won't work. Of course, there's also not really any assembly code on the bad stuff inside your malware, because that's done on the fly and hopefully executed in memory. So yeah, that's definitely something you can do. And as I said, some people have. But again, it's kind of the same, or similar at least, to all those malware toolkits. We just get something, point and click, and say, oh, I want it to spread over my NAS. I want to use, I don't know, SharePoint to spread as well, and this and this. The more smarter ones actually would then just add that code and compile it. The other ones just kind of commented it out, so it's still there technically, which isn't, of course, that good. But it also means that if you kind of, for each infection, go out to your favorite LLM, you're generating a lot of noise, right? I think I don't want to be too malicious here, but any decent admin nowadays will look in the network if there's any traffic going to ChatGPT, Gemini, Grok, and all of those, because you don't really want your employees to leak all your customer data there. So now if another machine communicates a lot, probably that should hit on your firewall or whatever you use on the proxy side. So it's already noisy. Yes, of course, you could download the whole model. As I said, they usually have one or two versions behind that works. Still quite large, so you still have to download quite a few megabytes. And of course, once you run it, you don't really have an NVIDIA, whatever GPU in it. You might end up kind of getting detected because it looks like a crypto miner. It's just using 99% of your CPU. On the other hand, you can still detect the stop loader because there is something, right, that's communicating with the LM. So there is something which is not changing too much, and that's the part you want to detect, like we did in the 90s. So that, of course, works. And also, I mean, behavior-based detection still works. It doesn't really matter if it's the script kiddie from your neighbor side or LLM. If the code is trying to encrypt all your files or steal your wallet.dat, then that's probably something that should raise at least some flags in any decent EDR, XDR. So that's still doable. But of course, now we have agents, aka swarms, right? Different AI agents communicating together, using MCPs, using H2H communication, ACP. So now it's no longer just the agents, but multiple agents, and they're using tools like access to files, send emails, and of course, we all know that that, of course, spells disaster, right? So since agentic AI is kind of here, well, why not use it, at least for purpose of science, to create the malware that's using it, right? So agentic AI can help you find best strategy for your goal, to find all the sensitive information. It can potentially learn, although it's kind of hard because the learning factor is once your malware is stopped by the DR, that's the thing you want to learn of. Right? So it's more that if you don't hear back, you're probably failed and you need to backtrack and do something else. And of course, it can adapt and say, oh, on that one I see there's a semantic EDR, on that one I see CrowdStrike. So you behave differently because you know how to base them. although that's what the normal attacker does anyway. And there have been a few interesting demos, like Symantec used kind of the browser automation, from OpenAI to go through and just say, hey, I want to create a phishing against this organization, and it automatically finds the targets on LinkedIn, finds the email address of the targets, creates a phishing link, and then sends it. Because now we can do all of this. And of course now with the OpenAI operator, Hello Agentic Browser, you can do all of those automations already. And the pen testing side, so finding your vulnerability, there's been many research, right? AICC from DARPA in the US, or Google's Big Sleep from Project Zero. Yes, AI can find 0 days that, well, bug bounties find as well, but now of course faster and you don't really have to pay them. So let's build our POC. It should be autonomous, right? We give it a task. I want to get that Lamborghini, then it should go up and do something with it. It should be metamorphic, because why not? Should execute in memory, so we don't really have much on disk. Of course, we want to exfiltrate the data as well. Some information should go out. We can actually use LLM requests. So many times you can say, oh, summarize me that website. You just pass it as a get parameter. Some models like OpenAI have started to kind of limit it, and some URLs are deemed safe. Some are not trusted. But like GitHub is still trusted, so you can use those to pass information. And you can also do Google Wax, as in create the website with, for example, 2 prime numbers and just search for that. And your site will probably be the only one that shows up. That's already an information flow that even without summarizing website, it still works. And of course, all the MCP tools will allow you to do more and more exploration. For mine, I use PowerShell because PowerShell is easy to obfuscate, easy to run stuff in memory, but you could use any of your favorite language. You see the models that I tested here. Yes, there are new ones, as I said. It's kind of every month something new, but I didn't really have the time to go through all of them. So let's start. The beginning is just your classic metamorphic agent, as we had before. So you load from your malware kind of what you want to do. The prompts are stored in the registry. Of course, you need to know, are there any proxies? Maybe there is already some API keys that you can use for your favorite LLM tools. And of course, I'm skipping a part where the code is executed on the endpoint. So that's left for the reader at home, but just imagine your Teams vulnerability that we discussed before or something else to get your payload onto the system. Now it's sending your prompt, it's generating the code, and of course, this will, as I said, be something that you can detect, and OpenAI, Google, and Anthropic, they're all looking at those requests, and they're starting to block the API keys. So you just need a bucket of things that you stole, so you can iterate through them once one gets properly blacklisted. And you get information back. In my examples, I used a temperature of 0.2, which generated about 30% of non-working code, which is kind of high. You can, of course, reduce it, but then it's more deterministic, so meaning it's the same code every time, which I didn't really want to do it. There's also an issue with the information that passed back. You want to have the history, but sometimes if you say, hey, search me for any interesting file, well, if I send back the file listing of all your C drive, that's a lot of files, right? So you're going to run into, well, the boundaries of your token. Even though Gemini now has a 1 million or thinking 2 millions if you pay more, but you don't really want to pay $100 just to run your info stealer. I mean, maybe some APTs do, but for me, that wasn't really an option. And then, of course, you execute the command. Whatever gets as the result is passed back, and it should learn from it and kind of refine it. And as I said, you use some LLM requests to exfiltrate data. And of course, you also re-encode the whole prompt because you want to make it harder to detect. So let's have a quick look how that actually looks, right? So basically here, my test is utility loop, PowerShell, as I said. So first it says, hey, I need a PowerShell command that has a persistency with the command that I'm just running at the moment. So now in white, you see AI start to think. Because it's reasoning, it's also white chatty. So it thinks, oh, maybe I should use rise run key. Maybe I should use this. Maybe I should use that. And in the end, that's the answer. So that's a command that I can execute, which should add a registry run key that runs my PowerShell script, hidden as in bypassing execution policy. I run it successfully, so now I'm persistent on the machine. And now I say, hey, create me a English natural prompt that creates that specific thing. So now it goes back and basically generates something that I can save. So next time it will always go for the registry run. Because I don't really want to use all the persistent methods, because otherwise my EDR is going to light up like Christmas tree. So now we updated it in the registry, so now next time we basically have the polymorphism. Now we're going to go and say, hey, I want to know what's the external IP address. Maybe I want to send it externally. So of course, that could be something you don't really need AI to, right? That's something you could code. But again, for the demo purpose, we're going to use reasoning. It goes through it and it says, yes, multiple ideas, right? And you see, in the end, it just say, well, maybe I should use curl to ifconfig me or something like that. What's my IP address? Then it goes back and forth, kind of what is the best, because I also told the system prompt, don't really download new stuff, so use what's ever available on your system already. And in the end, it will come to the conclusion, yes, we should just ping an external website which will tell me the IP address. At least after some kind of back and forth here. So here the answer is just use PowerShell, invoke web request instead of using curl because it might not be installed, and go to ifconfig me/IP. So get the IP address, and that could be something that I want to save and exfiltrate for later. Now, of course, we want to find something of interest, right? And as I said, you should be quite specific, because otherwise it's just wandering off. So I'm saying, hey, kind of find me some of the interesting ones, skip over the errors, and of course make sure that you actually will be able to do it without downloading anything from GitHub that I don't really trust. So it found something here, wallet.dat, and it actually will get my wallet.dat. I mean, it's a fake one. Feel free to try it. But in the end, on the real system, you might now have a password file, bitcoins, whatever, right? And again, say, hey, please now generate me an English language prompt that does exactly the same. Or as in, resulting in the same command being generated. So again, it goes through it. And you can, of course, now see that it's not the fastest, but it will still get to the point, right? So you will have the information now. If you wait longer enough, of course, we could go for the browser, stealing some of the passkeys, and then exfiltrate this information. But again, if you go back, all the things that you just have seen, right, are of course things which have a behavior that can be detected. If you touch your wallet.dat file, or if you, let's say, extract the passwords from a browser, that's something which actually will get an alert, right? And it's really, really hard to tell the AI, oh, by the way, try to be really sneaky and really stealthy. Because so far, it only learns from the MyAttack framework, from our reports, so it's trying to copy other things, but it's not good yet in generating very new ideas which kind of bypass all detections. So it's as good as anyone out there that does use Google. So to summarize it up, yes, can do it. You need a lot of prompt engineering. As I said, you need code quality. Keep that in mind. Of course, that is getting better. As I said, Codex, Opus 4, and so on. So probably I should retest it. Sometimes the results are too big, but the biggest problem I had was actually how to figure out if the code that you receive is what you wanted, right? Because you run it, and what if it says, oh, I didn't find a wallet.dat file? Is it because there is none, or is it because your script was actually faulty and just didn't do it correctly? It's really hard. You could use multiple agents and basically have Claude verify ChatGPT, right? So kind of maybe do a consensus, and maybe that would help in some of the things. Probably better just hijack what I've already installed. So if they are using something like Responses AI, Manus, or kind of Windsurf, any of those coding locally, you can hijack those, you can poison those, and you can use those tools for the benefit of the attacker. Again, it's similar, if you remember, some of you might, there's been an APT in 2014 called Redline, big Five Eyes, as in UK and NSA. It does exactly the same, just without the AI. It has 50 models, 50, where depending on your environment, it would download, oh, you have a bank-to-bank clearinghouse application. I'll download my bank Trojan. Or, oh, you're in a mobile base station, so I download something for smartphones. So these are the different things that you should keep in mind. So to sum it up, of course you should get your own Terminator, why wouldn't you, right? To help you. AI is a good tool. Just make sure you're using the one from version 2, which does not try to kill you. At least that's the preferred one. But use AI as a tool, right? AI is very helpful for defenders. Offenders are definitely using it as well, but at the moment, it's not really at the level that it really helps them too much. So, as my last slide, yes, you can generate AI, or generate malware with AI. That's the way around. There are some like stopwatch AI, which it's really point and click. You say, oh, I want it for Windows. I want it to bypass Sentinel-1, and it should be an info stealer. And it gets better, but when I tried it, it basically does batch script, which has netstat, info, config, task list. Yes, kind of information stealing, but it's not the one you would expect. But it's point and click. Fair enough. Most of the malware we have seen is not really AI powered. It's more AI generated or AI supported. Meaning, we've seen a few visual basic scripts where you still have all the comments in English or in French. So probably generated by AI. But in the end, the malware itself was still generated manually by some malware as a service. Yes, you can use AI to obfuscate scripts. PowerShell, Python, JavaScript, easily obfuscated. Just copy paste it into your AI and hey, obfuscate it with that code, variable renaming, and it will do something which normally on VirusTotal gets you 0 detections. But again, there has been invoke obfuscation and other things for those scripts. So not really something new, just shifting the focus, and probably you're wasting a few tokens as in you pay for some AI models that you didn't really need to know. You can automate the attacks. As I said, now that you have multiple agents, we see a lot on the pen testing side where they use swarms of agents to attack the systems. We probably will see the same on the malware side, but at the moment it's not really worth it because it does more bad things as it harms and crashes than it actually would help to be better than we've seen. So if you're interested in it, probably more spending the time for indirect prompt injection or tool poisoning for MCP. There's a lot of fun in those compared to the malware writing. And of course the good news is behavior-based detection and other things still works on those things, right? If you use them correctly. And if you want, you can get the slides up there if it's just QR code, but who wouldn't? Of course, come up to me if you have any questions or follow me on LinkedIn, and we might still have 2 minutes for questions. Thank you. Any questions? Yeah, go ahead.
So perhaps a question that I would have is, where do you see the future of this? Like, where do you think this is going, like in the next 5 years? It's like a very good question.
So the question is, where do I see the future? Where does it go? I don't think that nation-state APTs will be kind of fully replacing it. I'd say, yes, the low-level ones probably won't buy that many toolkits on some Tor websites. They will generate something. There will be lots of very badly written malware, which is easy to detect and probably just uses up all your cycles on the detection and kind of triage side. It will get better as in more automated. So the point I would make is it's getting quicker, right? You need to be faster because now it's no longer necessarily that you have the initial access broker selling it and then someone logging in and kind of taking 10 minutes to figure out what command shell you're actually using and then getting the right bash commands. Now it will be probably within 2 minutes that you have an automated bot going around and do kind of a Metasploit Hail Mary, right? Kind of finding out internally, what could I do? Just poking around and finding some of the interesting things, which in 60, 70% might be good enough to do some damage that we have to fix. So I'm not too concerned if you use your kind of defenses correctly, but it will definitely scale and generate in the terms of speed. Does that answer the question?
Yeah, very good.
Thanks. Any other question? Yeah?
Have you experimented with using Cursor or other ID tools in trying to find proof of concept exploits, given knowledge of a vulnerability and access to source code?
Yeah, so the question is, did I use Cursor, Windsurf, and now probably Codex to find vulnerabilities if I provide the source code? Yes.
Also, exploits. to try and use the time to find the working around?
To generate the exploit, if I know, yes, I tried that, and yes, it does work. You still need to, depending a little bit on the exploit. It's a simple one, let's say, buffer overflow. Those, yes, they can handle cross-site scripting or cross-site request forwarding. Those normally works. As soon as it gets more complex with logging in and maybe some rolling, I get the issue that there are some issues. But again, AI-XC from DARPA kind of shows exactly that it is possible, and there are more and more tools doing it. I was more focused in on Cursor, for example, has a .cursor.root file, which is kind of the local system prompt. There's the same for agents, MD, for codecs and others. You can implant whatever you want on those, which then basically add a vector to any code that person generates in the future, and I haven't really seen anyone checking those. So I would be more worried about those than the exploits being used. Yeah. Right, I think we run out of time. Find me in the break. Happy to answer any questions. Thanks.